In a conventional circuit, the bonding conductor, which is typically a green wire, connects the equipment grounding conductor, often a bare copper wire, at the electrical panel to all metal enclosures, outlets, and devices. Its primary function is to provide a lower impedance path for fault currents to flow back to the panel, thereby tripping the circuit breaker or fuse and clearing the fault. When an arc fault circuit interrupter, or AFCI, is installed in a circuit, it actively monitors the current flowing through the hot, which is typically a black wire, and neutral, which is usually a white wire, conductors. The AFCI is designed to detect specific electrical signatures indicative of arcing faults. If the AFCI detects a sudden and unexpected increase or decrease in current or other waveform anomalies characteristic of an arcing fault, it is designed to quickly open the circuit, thereby interrupting the flow of electricity and mitigating the risk of fire. The bonding conductor plays a crucial role in the overall operation of an AFCI-protected circuit because it provides a path for current to flow during an arcing fault. Specifically, when an arcing fault occurs between a hot conductor and a grounded metal enclosure, the fault current flows through the bonding conductor back to the electrical panel. The AFCI senses this increased current flowing through the bonding conductor, recognizes it as an arcing fault condition, and trips the circuit. Let's analyze a situation where an unusual interaction between an AFCI and non-AFCI bonding conductor leads to unwanted tripping. In the scenario described, the connection, or splice, between the hot and neutral conductors of two different circuits, one protected by an AFCI and the other not, would not typically cause the AFCI to trip on its own. However, the interconnection of the bonding conductors from the non-AFCI circuit to the bonding conductor of the AFCI circuit introduces a potential problem by creating an unintended closed loop. When the AFCI is energized or turned back on, current can flow through the interconnected bonding conductors from the non-AFCI circuit to the AFCI circuit. This flow of current can create an imbalance in the current flowing through the hot and neutral conductors of the AFCI protected circuit. The AFCI, being highly sensitive to current imbalances, interprets this imbalance as a potential arcing fault and consequently trips the circuit. The fundamental solution to this problem involves isolating the AFCI bonding conductor from the non-AFCI bonding conductor. By disconnecting the interconnected bonding conductors, you prevent the unintended flow of current through the bonding conductors during a fault condition. This elimination of the current imbalance allows the AFCI to operate as intended and eliminates the nuisance tripping. In more detail, consider the role of the equipment grounding conductor. The equipment grounding conductor, or EG, provides a low impedance path for fault current to return to the source. This path is essential for the proper operation of overcurrent protective devices, such as circuit breakers and fuses. The EGC connects the non-current carrying metal parts of electrical equipment to the grounded conductor at the service equipment. This connection ensures that in the event of a fault, the fault current will flow back to the source, causing the overcurrent protective device to trip and to energize the circuit. The bonding conductor, on the other hand, connects the metal enclosures of electrical equipment to the EGC. This connection ensures that all metal enclosures are at the same potential, which reduces the risk of electric shock. The bonding conductor also provides a path for fault current to flow back to the source, which helps to trip the overcurrent protective device. The AFCI is designed to detect arc faults, which are unintentional electrical discharges between two or more conductors. Arc faults can occur for a variety of reasons, such as damaged insulation, loose connections, or corrosion. Arc faults can generate a significant amount of heat, which can ignite nearby materials and cause a fire. The AFCI works by monitoring the current flowing through the hot and neutral conductors of a circuit. If the AFCI detects an abnormal current flow, such as a sudden increase in current or a high-frequency noise, it will trip the circuit. This will de-energize the circuit and prevent an arc fault from causing a fire. In the scenario described, the connection of the bonding conductor from the non-AFCI circuit to the AFCI circuit created a parallel path for current to flow. This parallel path allowed some of the current from the non-AFCI circuit to flow through the bonding conductor of the AFCI circuit. This current flow created an imbalance in the current flowing through the hot and neutral conductors of the AFCI circuit. The AFCI detected this imbalance and tripped the circuit. To correct this problem, the AFCI bonding conductor must be isolated from the non-AFCI bonding conductor. This will prevent the current from the non-AFCI circuit from flowing through the bonding conductor of the AFCI circuit. This will eliminate the imbalance in the current flowing through the hot and neutral conductors of the AFCI circuit and prevent the AFCI from tripping. Now consider the applicable sections of the National Electrical Code, or NEC. The NEC provides specific requirements for the installation of AFCIs and bonding conductors. Section 210.12 of the NEC requires that AFCIs be installed in all branch circuits that supply dwelling units. Section 250.118 of the NEC specifies the types of conductors that are permitted to be used as equipment grounding conductors. Section 250.130 of the NEC provides requirements for connecting equipment grounding conductors to metal enclosures. Section 300.3 of the NEC requires that all conductors of a circuit, including the equipment grounding conductor, be installed in the same raceway or cable. These requirements are designed to ensure that AFCIs and bonding conductors are installed properly and that they will function correctly to protect against electrical shock and fire hazards. Also consider the importance of proper grounding and bonding. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the overcurrent protective device and to energize the circuit. Bonding ensures that all metal enclosures are at the same potential, which reduces the risk of electric shock. When grounding and bonding are properly installed, it can help to protect people from electrical shock and prevent electrical fires. When troubleshooting AFCI tripping issues, there are several steps you can take. Firstly, visually inspect the wiring. Check for any signs of damaged insulation, loose connections, or corrosion. These conditions can create arc faults that can cause the AFCI to trip. Secondly, use a multimeter to test the continuity of the grounding and bonding system. This will help to ensure that there are no open circuits or high resistance connections. Thirdly, use an AFCI tester to verify that the AFCI is functioning properly. An AFCI tester can simulate an arc fault and verify that the AFCI trips as expected. Fourthly, isolate the circuits. If you suspect that a particular circuit is causing the AFCI to trip, you can isolate that circuit by disconnecting it from the panel. If the AFCI stops tripping after the circuit is isolated, then you know that the problem is in that circuit. Fifthly, check for shared neutrals. Shared neutrals can cause AFCIs to trip. If you suspect that you have a shared neutral, you can disconnect the neutral conductors from the panel and test them with a multimeter. If you find that there is continuity between the neutral conductors, then you have a shared neutral. Sixthly, consider appliance compatibility. Some appliances, such as older motors and electronic devices, can generate noise that can interfere with the operation of the AFCI. If you suspect that an appliance is causing the AFCI to trip, you can try plugging the appliance into a different circuit. If the AFCI stops tripping after the appliance is moved to a different circuit, then you know that the appliance is the problem. Remember that working with electricity can be dangerous. If you are not comfortable working with electricity, then you should hire a qualified electrician to do the work for you. Also remember the importance of regular electrical inspections. Regular electrical inspections can help to identify potential electrical hazards before they cause problems. Electrical inspections should be performed by a qualified electrician. Furthermore, understand the different types of arc faults. There are two main types of arc faults: series arc faults and parallel arc faults. Series arc faults occur when there is a break in a single conductor. Parallel arc faults occur when there is a short circuit between two or more conductors. AFCIs are designed to detect both series and parallel arc faults. However, some AFCIs are more sensitive to one type of arc fault than the other. It is important to choose an AFCI that is appropriate for the type of electrical system that it will be protecting. Another point to consider is the location of the AFCI. AFCIs should be installed in locations where they are easily accessible and where they will not be exposed to moisture or other environmental hazards. AFCIs should also be installed in accordance with the manufacturer's instructions. Be aware of common causes of AFCI tripping. Some common causes of AFCI tripping include damaged wiring, loose connections, shared neutrals, and appliance incompatibility. It is important to identify and correct the cause of AFCI tripping to prevent future problems. Finally, consult with a qualified electrician. If you are having trouble troubleshooting AFCI tripping issues, you should consult with a qualified electrician. An electrician can help you to identify the cause of the problem and recommend the appropriate solution. Remember that electrical safety is paramount. Always take precautions when working with electricity to protect yourself from electrical shock and fire hazards.